All right, let's see how this problem goes. This is section 7 of the ASTAC, problem number 8. So we're given that a claim, probability of a non-claim for coming out of pool A is 0.6, so there was no claims on that particular pool. And if there was a claim, and of course we know it's going to be 0.4, and that it's going to be normally distributed. So if you had a claim, it's going to be normally distributed. And then the same was given, they first told us the probability of not getting any claim in B, which is 0.7. And then so obviously getting one claim or more would be 0.3. And then it was normally distributed between 9,000, and of course the variance is 2,000 squared. Claim A is independent from claim B, and it says find the probability that claim B is greater than claim A. First thing we have to look at is they're independent and they're normal, right? And if you sum up independent normals, you get the sum of a normal, and you get the sum of the variance. So we can have a new random variable where you sum these up, and then you'll get that. Just wanted to say that. I'm gonna use that here in a second. So we have all these probabilities here, and what we need to do is look at these conditions. Just like we do for boundaries of figuring out integrations or summing up anything with a discrete probability, our boundary here is that, in the sense that we need to figure out when is this acceptable, okay? So say for instance, if we have basically 4 conditions here, all right? First condition is that there is no claim. There is no claim for A, and there is no claim for B. Well, that probability would be 0.6 times 0.7, right? Because we know with independence, we times them. So we get this number here. And then what if we get no A, but we do get claim B, right? Well, that's a probability of 0.6, and then claim B is 0.3. And then we do get claim A, but we get no claim B, right? So claim A, we do get 0.4, but claim B, we do not get. It's 0.7. And then we get both claims here. We actually get both claims here, which is 0.4, 0.3. So basically this is discrete in a sense because it's like a mixed distribution. We need to know these probabilities first because the condition is based on if we have it or we don't have it. And then after that, we use those probabilities then to help answer this particular question here. So the probability that we get no claims here, I mean, for us is basically 0. We really don't care. Now there is going to be a probability here, right? But once we add it all up, it's 0. The probability that we get no claims in A, but we get a claim in B, that means B is greater than A, which is basically 100% of the time. Because we get none in A, and we get something in B, this is 100% of the time. So we want this one, all right? It'll be 1 times that probability. And what is that probability, right? It's 0.18. It's 0.18. I'm just gonna leave it that for right moment. And then, what about this? We get no in claim A, but then we get something in claim B. Well, we know that's gonna be 0 times, right? That's gonna be 0, right? because it doesn't matter what that probability is. Now we can figure that probability out, right? I mean, if we really wanted to, I think it's what is that? 0.28, is that correct? Yeah, 0.28 off the top of my head. This is the probability that we want right here. This should be, I think it's 0.12, is that correct? I believe that's correct. It is. Good. I should do my math. I'm doing basic math, I'm not even thinking about it. But, so now I have my probability that I need there. One is a condition. I know for sure every time, because I get a claim in B but not an A, so that's going to be 100% of the time. So all I need to know now is what is this one? What is this particular expectation? And that's what we're going to use this rule here, where we're going to make this probability of C minus CA, it's going to be greater than 0. Okay? And we can sum them up and do their variances and stuff like that, and that's basically what we're going to do. So we sum these up, right? 9 to 10, basically negative 1,000, divided by the square root of well, let's just be 2,000, shouldn't it? No, huh? Right? Has to be greater than 0, right? So we'll get some kind of negative, not 0.5, is that correct? And did I do it wrong? I'm just going it pretty fast. I'm pretty tired. I'm just gonna leave this out. But anyways, what we're gonna do is we're gonna get basically this I here, and it's going to be, well, probably actually probability of Z being greater than, what was it? 0.35 something, 0.35 some change, 36, and then it'll be like 1 minus all of that there, I believe. And then we get this 0.363. I'm just using the solution to do this particular problem. It's pretty late at night. Throw that number right there. So then we'll have our true probability. Which will be 18 plus this junk here, whatever that is. I didn't even have to write it. I'll just write what the solution answer was. 0.223. 0.223. And I'm sorry that I didn't do this last portion right. I'm a little tired, a little winded. And I don't care, I'm gonna leave it up there. But the point is, needed to do these conditions here. Needed to do those conditions because obviously you know you got a claim or you don't, and we're going to use that. We're going to use this independence to find those probabilities, and then after that we use those probabilities to figure out their expectations, okay, or the amounts that we think is going to happen. That's the way I like to do it. I know you can formally do it using conditional expectation. I think that's a little bit more confusing, a little bit more extra work. I think trying to keep it at a higher level like this, if you understand what's going on, it's just easier and simpler to do. And that's what I want to be at on an exam. I don't want to have to get dive too deep right away. Maybe those last few problems, I'll go further deeper, but for now I'm gonna try to keep it up at the top, realizing that I have normals, knowing that some of those normals are normal, I know what the variance is, I can figure that out. But use these conditions. Always find the conditions. It's always about boundaries and conditions. It's logic more than it is mathematics. Gotta find these. Those are the most some keys. And then using those to actually solve the problem. Anyways, good luck and good studying.